Welcome to a new DIY Engineers video. In this video, I'll go over Bitwise Operations and Masking with OpenCV. I'll be using a Raspberry Pi, but this applies to OpenCV and Python in general. So let's start with Bitwise operators. We have AND, OR, XOR, also called exclusive OR, and NOT. I think it's easy if we just start right away and explain out the output. So we'll just go ahead and start with AND, OR, and XOR and go through the code. So as a reminder, I'm inside the virtual environment and the specific folder, and I'll be running the commands from here. And I'll be writing the code here. Let's start with importing NumPy and import OpenCV. I'll then create a black background image. And then as we've done in other videos, we're gonna draw shapes over it. So let's start with the circle and then we'll do a square. Then let's display the shapes. And then after that, we'll do our typical wait key. All right, let me save this. Missed a comma somewhere here. All right, so there it is. We have a circle and we have a square. So now let's continue with the code so that you can see the bitwise operations. So let's start with AND. We'll call it BW underscore AND equals CV2 bitwise underscore AND. And then we'll just do circle and square. So this will be the AND of the circle and the square. As you'll see, once I show the image, it's basically going to show the intersection of the circle and the square. So we'll do CV2 IMShow. We'll call it the window AND. And we'll pass this image. And let's just run that. So you can see here, if I overlap the circle and the square, this section here is the overlap between the two, and that's what AND generated. I'll show OR and maybe it will become a little bit more obvious. So let's do OR now. And while I'm at it, we'll just go ahead and do XOR as well. Let's try it. All right, so we can see it here. This is OR, and it's basically the overlap of the circle and the square. The AND is basically the intersection of the circle and the square, so only show the area where they both overlapped. That will be here. Right, you can see it. And then XOR is basically everything where they both didn't overlap. You could think of it as OR and subtract or remove the AND, right? That's the whole, or just the areas that they didn't overlap. All right, let's look at NOT. We'll call it bitwise NOT equals CV2 bitwise NOT. And we'll just do circle. And let's run that. So here it is. So this is NOT, and let's just look at the circle. Here it is. So this is a circle where I had black and then white in the middle. NOT just inverts it. So let's try all this, but with colored images. At first, we just did black and white. But basically, the OpenCV bitwise operations can be applied to both grayscale and colored images, but the bitwise operations will happen on a per channel basis. So for grayscale, since the image only has one channel, the bitwise operations are applied to the one channel that we're working with. And for colored images, they're applied separately per channel. Now, I did set up this as a 3-channel image, so they were operating on the 3 channels. It just wasn't as obvious because we had everything in black and white. So let's see what happens if I change this to a 0. And this as well. So we're doing blue for the circle, and we'll just do red for the square for now. So let's hit save and run that. All right, so circle is blue, square is red. What is AND? AND is nothing, because now there was not a single channel where any of the colors overlapped, right? There was no overlap between blue and blue or red and red, so you get nothing. Or you get this. You had some blue here, some red here, and then they overlap. You get this pink or purple, whatever that is, and that's the OR. XOR same thing. And then not, the opposite of blue is yellow, and that's what you get here. And then the opposite of the black is white. Now what happens if I go ahead and we make them both blue? Let's try that. Circle, square, and it's basically now the same as before, except it's blue instead of a white circle. Okay, same thing. Same results, just blue. Now what happens if I keep the blue, but I'm gonna make the square have some green? So circle blue, square, what is this, cyan? And then right? The overlap of the circle and the square, they both have some blue, and this is the overlap. It's the blue portion on a per channel basis, because the other one had no green. So then the OR, it includes both. XOR is what wasn't included in both. So we subtracted or eliminated from the blue circle the AND, but we also subtracted from the cyan the AND, which landed at the green, right? The green portion that we added just before running this code. And then the NOT, again, is still the same yellow. All right, hopefully that made sense. Let's now go over masking. So we're gonna use the image of the deer that we used in the past example. So just know we're gonna need that. Now, what is masking? Masking is the process of selecting or isolating a certain region of an image by defining a binary mask, which is essentially a mask ends up being a black and white grayscale image, where white or pixels of value 255 are the region of interest or region to keep, and black is anything with 0 is to what we ignore. So you apply a mask to an image so that only the regions corresponding to the white are kept and the rest is ignored. Again, let's start with the deer. So we're gonna do image cv2 imread open parentheses. Remember, we're pulling this from the imgs folder. That's the deer file. Okay, I'm gonna go ahead and resize this. You don't need to, but it'll make it easier to work with the image for now. And let's just show that image for now. I'm missing one parentheses. All right, there's the deer. You've seen it in the previous videos. So now let's go ahead and create a black image, which we'll use for the masking. So black underscore img equals numpy zeros. Now I want, or it's critical, it's not that I want, it's critical that the mask be the same size as the image you're working with. So I'll just use the img.shape to pull the same size. And we'll make the type, so D type equals uint8. So now let's go ahead and create a mask. So we'll say mask equals, and I'm just gonna draw a white circle and a portion of the image. That will be the region of interest. I just wanna focus it on the face of the deer. So I pulled the exact location and rough size. So let's just do that now. We'll place the black image. This is the location of the circle, specifically the center of the circle. Radius of 45. It'll be white, and we'll fill the circle. So now let's just show what the mask looked like so far. Here's the mask, and here's the deer. You can see that if I overlap these, you'll see what I get. So let's get the mask deer. So I'm doing and, passing the image twice, since that'll ensure 100% overlap. And then all we have to do is say mask equals, and then pass the variable we called it. We called it mask right here. So I'll just say mask again. Close it, and let's just show that. Let's run it. There you see it. So we went from the deer, we created a mask, we overlap with the mask set up, and this is what you get. So if I wanted to do anything to this image, I will be focusing on the circle with the deer in it. All right, let's try something a little bit more complex. So let me save this as, and we'll create a revision 3, so v7r3. So let's see, I'm gonna get rid of this, or let's comment it for now. I'm gonna pull a new image. So I took, if I go here, pull my DIY Engineers logo. I'm gonna be using that. So I'll say logo equals CV2. So let's just run that for now. you can see I have the deer, and I want to put the logo somewhere here. We'll overlap the two. So now, since the logo will go in the top left corner, I want to create a region of interest of the side of the logo. So we need those to match. So let me generate the region of interest. We'll call it rows, comma channels. Sorry, I forgot the columns. Rows, comma columns, comma channels. And that is simply equals to the logo shape. And then we'll define something with the ROI, which is the region of interest. That'll be equal to the image portion of the array that goes from 0 to rows and 0 to columns. So if you think about it, my logo image is smaller than my deer image. So we know that it has a bunch more pixels in the deer one. I define the region of interest as a section that goes from the top left corner of the deer all the way to covering as many rows and columns as my logo. And I'm now pulling that section from the deer image and calling it a sub image called ROI, which is region of interest. So let's go ahead and take a look at that. So here it is. It's this portion right here from this corner. Now it's this, and I will overlap the logo there. All right, so now let's create a mask of the logo and create its inverse mask as well. So how do we do that? First, I'm gonna change my logo to grayscale. Now we haven't done thresholding yet. That'll cover in another video, but for now I'll use it for this example. So basically, I'm gonna keep all pixels that are between 240 and 255, so only the super wide ones, which will be basically the letters of the logo, is what I'm keeping. Everything else will be removed. So that'll be the mask. And then I also need the inverse of that. So here's what we're gonna call it, mask inverse, or mask IMV. And we'll do CV2 bitwise, not, and run the mask. So I think it makes sense to visualize all those three. All right, let's test those. Forgot to put parentheses here. So this was the logo. This is what happened to it after I put it in grayscale. And then I calculated the mask, which was basically the thresholding, meaning ignoring anything that is not super white, which gave me just the white letters. And then I took the inverse of that and I got this. So if I was using this as a mask, I would keep the white, which is the letters. And if I wanted the inverse, I would just keep the white here, which is everything but the letters. That'll be important in the next steps. So now let's black out the area of the logo in the region of interest. So let's just call this one the overlay foreground. And we'll say cv2.bitwise underscore and here's where we do what we just did in the prior example. Logo, comma logo, and we'll set the mask equal to mask. And let's do the same for the background. So not exactly the same, but similar. Overlay background, we'll do CV2 bitwise, and we'll do it for the region of interest. So ROI, and the mask will be the inverse mask. Okay, so let's just show those. You don't have to show all these individual steps with IM show. I'm just doing it so you can get a visual as we test it. So the overlay foreground will be this. This is the overlay background. So what happened here? Here's my region of interest, which was the top left corner of the original image. And now I removed anything that has the outline of the image that I want to then add on top, which is this one. Now it would look a little bit more interesting if it wasn't just white letters, but this could be colored with stripes and everything going on here. And I would have now a slot of black ready for me to add that on top, which is the beauty of what we're doing. So that will be the next step. So we'll just do combined equals cv2.add, and then pretty much just add the two images. So just because we're checking step by step, let's look at it. All right, here's combined, and you can see now that is basically what we wanted to put in the top left corner. It has the fancy deer picture background with the portion of the logo that I filtered and now goes on top. Now, since it doesn't look super interesting because it's just a bunch of white letters, maybe I can change that threshold just so you can see what I'm doing. So what if I made this, I don't know, 150. Okay, now you can see I keep a part of the background image on my logo, and it gets overlapped on the deer image, right? And you can even see it on the mask. Let's look at the mask. Or on the background, we're now cutting out some of that and putting it in black. This is what we're keeping. And you can see the mask. I mean, it looks pretty cool. So we'll continue with this. And now let's go ahead and replace the pixels. So this is the final step to put it in the final image. We're just going to say that image from that range that we originally specified. So basically this region, which was the region of interest originally, but I'm referencing from the original image, will be equal to combined. What is it doing? It's just replacing the values that originally had in the image for this range with whatever I have in the combined variable. So now let's just display that. We'll call it final, and we'll put the image. And there it is. You have the deer, the full image, the DIY Engineers logo, and I kept some of the yellow markings from the logo. Alright, that's all for this video. I hope you found that helpful. If you did, give us a thumbs up and subscribe. See you in the next one. Bye.